Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. In this video, I am going to teach you how the recognition of tokens, that means tokens, how it is recognizing. Okay, for example, I told you in a lexical analyzer, the source program is converted into token, but compiler, how it is recognizing the token. That is the concept we are going to, I am going to teach you today. The first step of recognition of token is by using the grammar, it is recognizing token. Okay, grammar is needed to recognize the token. For example, if you take this as a grammar, you know what is grammar. In a TOC, I taught you what is grammar. It's a collection of variables and terminals. Okay, and also production, G equal to VTPS, variable, terminal, production, start symbol, etc. That is grammar. I can say this is a grammar. Okay, this is a grammar. And grammar, I am going to teach you in the next unit very deeply, but you should know what is grammar, because already I taught you in the theory of computation. Okay, statement, if expression then statement, and if expression then statement and epsilon. Okay, by using this grammar, I can we can recognize the tokens very easily. Okay, so here if is a terminal, expression then statement. Okay, expression is a terminal, and then is a keyword, and epsilon is a terminals. Okay, so by using this grammar, we can recognize the token very easily. So token is recognized by using the grammar. Okay, and if you see, expression is terminal, relational operator and terminal, and terminal is ID and number. Okay, so by using this grammar, we can recognize a token. For example, see, if that is terminal, that also if, then that is a terminal, that also then. And relational operator, we know operators less than or equal to, greater than or equal to, not equal to, etc. And ID, you know, ID is a identifier, what the programmer is, or the programmer is giving the input, that is the identifier, value. Okay, identifier. It may be a letter or digit or both format. Okay, so what is the use of star? Star is a closure property, one or more times. For example, we know, we studied, right, A plus B the whole star, or B star, or 2 star. Star means the number of time occurrence. I can write 2, or 3 times 2, or 4 times 2, etc. Okay, that is the use of star. And number, you know, it a combination of digit as well as terminal plus or slash, etc. with question mark, etc. Okay, so this is the terminals, and this is the keywords that is related to this expression. Okay, by using this only, the tokens are recognized by the compiler. Clear? Okay, so next one is transition diagram. We already I taught you what is transition diagram in a theory of computation. Once again, why we are using transition diagram in a compiler? Okay, that is, lexical analyzer need a transition diagram because all the tokens are taken from the transition diagram as well as transition table. Okay, so one small example, if it is less than, relational operator less than, so how it is, you know what is transition diagram? Transition diagram, start symbol is denoted by a circle with one arrow, and end, that is accepting state, is denoted by a double circle, and these are called as edges. Okay, these are connecting edges. So this we will say as a transition diagram. This is a state 1 or 2, or I can say A or B, etc. Okay, this is the starting state, this is the accepting state, and this is the connecting edges. Okay, how the tokens are identified by using transition diagram is the state 1 and 2, if it is less than, okay, and if I use the third state, and this is not an accepting state, if it is the less than or equal to, how it is identifying this operator by using a transition diagram is the state 1 and 2, it is less than, okay, and then the state 2 is connected with 3 is connected from the state 2. If it is accepting state, this is equal to, the output is relational operator less than equal to, less than or equal to. Okay, if it is less than, how it is identifying is, here the output is relational operator less than. Okay, if it is greater than or equal to, how it is connecting is, the state 1 is connected with the state 4, this is greater than, and the state connected with the state 3, and here the output is relational operator greater than or equal to. Or I can write like this also, the state 4 and it is connected with the state 5, this is, if this is equal to, and now the output is relational operator greater than or equal to. So similarly we can write all the relational operator less than or equal to, not equal to, like that. Okay, so by using the transition diagram or transition table also, the compiler is finding the relational operator, or it recognizing the relational operator. Okay, so this is the recognition of token, and the next topic is compiler construction tool. Compiler construction tools. Okay, so what is the use of tools? I told you, in order to create our compiler portability is enhanced. In order to make the compiler portability is increased, we are using the tools, right? Compiler efficiency increased by buffer, okay, but compiler portability is increased by tools. So we have few tools to develop all the phases of the compiler. What is the first phase of compiler? Lexical analyzer. So what is the duty of lexical analyzer? Source program into token. For that we have a tool, okay, that is called scanner generator. Okay, so this is the tool which is used to convert source program into token. So this is the tool for lexical analyzer, that is phase 1 of the compiler tool. Okay, so all the tool have input and output. Okay, so this scanner generator have regular expression as an input, and what is the output of scanner generator? What is the outputs? That means what is the output of lexical analyzer? Tokens. So input is regular expression and the output is tokens. Okay, so what is the use of what is scanner generator? It is a tool which is used to convert source program into token, that is lexical analyzer tool. Okay, so the input is regular expression and the output is token, right? So this is the phase 1, that is phase 1 tool. And the second, what is the phase of compiler? What is the second phase of compiler? That is parser generator or syntax generator. Okay, so second tool is parser tool. So here also we have a input, that is context free grammar as an input. Okay, so what is the input of second phase of compiler? That is token, that is context free grammar. And what is the output of second phase of compiler? Parse tree. So context free grammar is an input and the output is parse tree. Clear? Right. The third tool is syntax directed translation engine. Syntax directed translation engine. Okay, so this is the third tool, and you know, first phase of compiler is lexical analyzer, second phase of compiler is syntax analyzer, third phase of compiler is intermediate code generator. So this syntax directed translation engine is the tool for intermediate code generator. Okay, so what is the duty of intermediate code generator? It accepts, or the input of intermediate code generator is parse tree, and it produce intermediate code. Okay, so the syntax directed translation tool duty is it accept or it asks the input parse tree as an input, and the output is intermediate code as an output. Okay, so this is the duty of this is the tool for intermediate code generator, that is syntax directed translation engine, and it uses for some routines, that is some protocol, okay, or some algorithm to convert parse tree into intermediate code generation. Okay, and the next tool is automatic code generator. automatic code generator tool. So we know in the phase of compiler we have a phase that is automatic code generator. What is the duty of this automatic code generator? That it accepts the input from the intermediate code, that is intermediate code as an input, and it creates an assembly code. Okay, so it produces output is assembly code. So that this automatic code generator tool is used to convert intermediate code into assembly code. Okay, assembly code. This is the tool which is used to convert intermediate code into assembly code, right? And the last tool is data flow engine. Data flow engine. Data flow engine. This tool is used by the programmer or the developer, compiler developer, because this is the paperwork only. Okay, this tool only is the paperwork. That means the programmer will create a flow chart where the control want to go from one state to another state, or from one phases to another phase. That type of work done by this tool, and this tool is an programmer tool, that is only the paperwork. Okay, so this is the compiler construction tool. So you have to understand the phases of compiler. The first phase of compiler is lexical analyzer. For that we have a tool that is scanner generator. That input is regular expression. Second one is parser generator. The input is context free grammar. So this is the second phase of compiler tool, and this is intermediate code tool, and this is automatic code generator tool. This is the data flow engine tool. Okay, and another thing is the lexical analyzer, syntax analyzer, and intermediate code. These are comes under front end of the compiler. Okay, that is programmer only develop a code, that is a front end of the compiler, and remaining phases like automatic code generator and code optimization and intermediate code, these are the back end of the compiler. That is operating system only performs the operations. That is the back end of the compiler. Okay, so first three phases front end of the compiler, remaining phases is the back end of the compiler. Okay, so in this video lecture I taught you recognition of token as well as compiler construction tool. Both are different question, both are 4 mark question. Okay, thank you.